All right. The golden age of microbiology that began in the mid 1800s, and it was really all about Louis Pasteur, although there were several other people that contributed to it. But if I had to pick one, it would be Louis Pasteur. They were searching for answers to some questions, and I listed them here. Is spontaneous generation possible for microbes? What causes fermentation? What causes disease? How can we prevent infection and disease? And they really had two interests at this point: disease, certainly, and also fermentation, because the wine industry really could depend on quite a bit on understanding how fermentation creates wine and other drinks like that. So there was some economic interest, but there was also some public health interest in understanding microbes. So once we knew that microbes existed because of the microscope that Leeuwenhoek made, and Leeuwenhoek was before the 1800s. So I would say I think he was even before the 1700s, so maybe late 1600s. And so by the mid 1800s, then they were pretty they were aware of microbes, but they wanted to know more. So first, we're going to address this question: does microbial life spontaneously generate? Spontaneous generation was something proposed way back by Aristotle. It was really the concept that something alive could form from non-living matter. We often use a term for this called abiogenesis. That means life, creation of life from nothing, from non-life. So basically, something alive would just appear, almost magic. Certainly in science, that we wouldn't subscribe to something like that. And by the 17 and 1800s, scientists were no longer subscribing to a world in which there was magic, and so that is, kind of the impetus for some of these questions. And we didn't know if living things arose from asexual reproduction, sexual reproduction. So they were trying to figure out where do microbes come from. That was a big deal. And like I said, Aristotle was 300 BC, and that idea of abiogenesis lasted for a long time. And so now we're after the Dark Ages, we're into the Enlightenment, and you have a scientist named Redi who did an experiment. He put decaying meat in a jar, and when he left the jar open, maggots would appear. And that's because flies would land on the meat and lay eggs, although initially the eggs are invisible, but then they become visible when they grow and get bigger. By then the flies have gone away. And so, that really led to people thinking that the maggots came from nothing. They just formed. But now we know that flies came in and laid the eggs, and then as the eggs got bigger, we couldn't see them. And but what he did was he put a lid on the jar and saw that maggots never came to that meat. So that's the image in the middle. And then they thought, well, maybe it's because you're blocking the air. So he put like a cheesecloth, a loose fabric, but a fabric over a jar so the air could come in, but obviously the flies couldn't. So again, the no maggots. So they started to actually come up with some actual evidence that put into question Aristotle's theory of abiogenesis. And there were some other experiments that were done, but I really want to get to the experiment by Louis Pasteur. Some people call Louis Pasteur the father of microbiology. Some people call Antony Leeuwenhoek the father of microbiology, but it doesn't really matter. But they're both important. But Pasteur did some experiments where he had kind of a broth in a special glass container. And you can see the picture on the left. He put the broth in this container, And the opening to the entire container was at the very end of this long neck tube that was folded by glass blowing into an S shape. So he called them the swan neck flasks. And he put the broth in the main part of the flask and boiled it. And he let it sit, and he noticed that it never got cloudy. It never got contaminated, let's say. It never got nasty. But he knew the air was able to move in and out of the swan neck. And after a while, he left it there for a long time, and it never got cloudy. It never got nasty. And he noticed that there was some dust settling in one part of the S, which you can imagine just from the air, it'll just kind of settle in there. And so he did kind of an important experiment. He would he eventually tilted the flask to get the broth to go down through the neck till it touched that dust, and then he put it back upright. And the next day, the broth was completely cloudy and growing stuff. And so what he figured out was that dust had microbes in it, and that if it touched the broth, it could grow. And so this was a very important moment in microbiology. And really, there were some other things in motion, but microbiology is often given a lot of credit in terms of developing the process that we now call the scientific method. Because in the 1700s and 1800s, there's this period of looking at things through a logical worldview and not a worldview that was very common prior to that period. So it used to be before that period that people looked at they thought there were curses and magic and all kinds of things along this line. But now we're looking at things from a logical standpoint. We're looking for evidence. We're looking for data. And so really it led to the formulation of the scientific method. And the scientific method is just a logical way of determining whether or not some idea you have is correct. And you continuously test your hypotheses, and it's just a process that we use currently, certainly even still. And but it was really new in those days. I mean, that was a very different idea, a different way of doing things. So in this day and time, we accept this as just a logical way of doing things. All right. One question they also had, and this was, like I said, because the winemakers wanted to protect their businesses. It turned out that things could get into the wine that spoiled it. And so they were interested in figuring out what it is that is spoiling the wine. Some people thought it was just air. Some people thought it was these microbes. And so the winemakers actually put a lot of money it's kind of interesting, into research in those days in the 1800s about regarding microbiology, because they really wanted to increase their alcohol production and prevent spoilage of their product. And so I think that's kind of interesting, but it's very practical. So, of course, like I mentioned, Pasteur was ultimately not, maybe not during his lifetime as much as it now, believed to be kind of the real father of microbiology. His name is attached to a process called pasteurization, which is, you may know, the process in which you heat liquids to kill bacteria, and that way they can last on the shelf quite a bit longer. So a lot of food products are pasteurized, certainly milk, but other products are pasteurized. Now, pasteurization does not involve heating it for so long that all the bacteria are killed. But there is something called ultra pasteurization, which heats it to a point where even more bacteria are killed. So if something is pasteurized, it still has a small amount of microbes in it. And that's why eventually something like milk will spoil. But it certainly lasts quite a bit longer with the pasteurization process and also with refrigeration. And so the work that Pasteur did really it really helped with industrialization of microbiology. In other words, using microbes for manufacturing. And I put a list here. You don't need to memorize the list, but you probably have some awareness that cheese involves the work of microorganisms. I don't know if you probably know alcoholic beverages. We talked about wine, but vinegar, soy sauce, yogurt has a lot of microbes, bread. So all these things rely on the work of microbes to create these products, and they're very important in terms of our economy, certainly. And then there's non-food products that are listed down here. All right, so here I'm going to take a break, and you can study this section. And when you're ready, move on to my third lecture segment.